Hello, everyone. Figure we'll get started. We'll see if some folks tire of brass and come on in. Not that you can never tire of it. That's why this is such a popular tourist destination. I come here quite often. So I'll just start real quick, tell you about myself. My name is Konstantinos. Even though my title is CTO, basically for the last 14 years or so, I break into banks for a living. That's what I do, pretty much. Over 80% of our clients at BT for ethical hacking are financials, so I pretty much specialize in that. And as a result, kind of early, I ended up finding blockchain, not like the day the paper came out, but maybe, like 2 weeks after the paper came out. In all seriousness, yeah, I got into the cryptocurrency thing very early because of my banking stuff. And it's been quite a wild ride. If any of you guys do ethical hacking, you know that with code, you never go in, take a look at it, and say, wow, this was so mind-numbingly beautiful, it needs no remediation whatsoever, right? That just does not happen. There's always something in the report, always something to fix. Well, what's interesting about smart contracts in Ethereum is once you publish a smart contract, like everything else on blockchain, it's there forever. Forever. No, so that's not such a great situation. So obviously, smart contracts is something that needs a little extra security look. And if you want to see what I say on the subject, you can follow me at Constant Hacker on Twitter. So when Satoshi wrote that first paper in 2008 to launch Bitcoin, he had some altruistic goals, and you can argue that some of them were met and some of them will never be met. The idea of bringing banking to the world, half the world can't access banking, so that's a good goal, The idea of making this money that doesn't have double spend problem. If I email you a picture, we both have the picture. If I email you $10, we better not both have the $10, right? So all that kind of stuff was solved. But then, recently Bitcoin has had its own issues. It's become expensive for transactions, slow, all that kind of stuff. Well, on the other side, there's the other world's big blockchain, and that's Ethereum. What separates Ethereum is that it's more of a global computer. It's a Turing-complete system. So rather than just being a way to send money back and forth, it's a way to do actual intelligent computing, save state, interact with folks. So you're literally renting time on a global computer. So that's what separates Ethereum. And while people will try and write things that work with Bitcoin, kind of like smart contracts, that's not really the case. Only Ethereum truly supports this sort of thing. And what have we put all that great power to? Cats. What else are we going to do right now? So for some reason, in the fall, we found these digital Beanie Babies taking off. People love the idea of buying their own unique cat, breeding it, and making new cats. And for some reason, this was popular. I really couldn't get into it, but other people did. So much so that in November, there were about 6 times the pending transactions on Ethereum because of this game. So while people were trying to do legitimate things, everything was crawling to a halt. Ethereum started behaving like Bitcoin. I mean, it was like slow and then sluggish. So there were some fixes instituted, including gas alteration. We'll talk about gas in a bit. But in December, people were spending about $100,000 max for these things. So talk about insanity. So every once in a while, a great idea can be, corrupted, but this did bring about something interesting, ERC 721 for non-fungible tokens. And the idea there is that you can sell things with tokens that aren't real. So there are some possibilities. This company OpenSea started, you could sell software licenses maybe. Things that aren't really real, but they have real value. More value than, cats. But smart contracts is really where it's at. So what's great about smart contract is it's a bit of code, business logic. It runs on the EVM. It's semi-autonomous, so once you get it running, it runs kind of forever. It is possible to have it point to a newer version. So even though what I said is true, yeah, they stay on Ethereum forever. You can, if you find a huge flaw, point to a newer version, and the old one will just kind of sit there as an artifact of your mistakes. So if you don't like your mistakes being public, again, the blockchain really makes them public forever. These are limited only by creativity. So you'll hear all sorts of use cases for smart contracts. I've heard everything from let's say one day we can have Uber without a company in the middle. You can just have smart contracts negotiating rides with people and just taking a little cut to run the program, and that's it. That'd be kind of nice, Airbnb without the company, all sorts of possibilities. People want to use them for real estate, for all sorts of transactions. So basically, they usually have money connected to them in the form of ETH. So whenever there's a security problem, that money can sometimes move. So why would we look at smart contract security? I mean, I could think of billions of reasons, literally billions. When the DAO hack happened 2 years ago, 3.6 million Ether were moved using a vulnerability we'll look at in a moment. If that happened today, it would be a $2 billion attack. How often do you come across an ethical hack that, hey, look, that would have been $2 billion? Almost never, you know? And this was super fast. It was a blink of an eye, and it caused a fork and all sorts of issues. Parity wallet more recently suffered 2 attacks, both of them numbering in the many, many millions, 32 million, and then, as we'll see, a staggering amount in the one after that. So these things happen, and there aren't enough people looking at it. Believe me, I'm tired. I'm the only guy in my company who looks at these things. But the demand is growing. So this isn't just an isolated thing. We find that the problem isn't going away. There was a study done using a new tool, and we'll look at that tool in a sec. And they looked at 900,000 smart contracts, almost a million actually. It was like 970,000. Now, that's a lot. You know, most of you probably even know there are that many smart contracts. Well, they found that 34,200 of them are vulnerable to serious money-damaging attacks. Okay, so the attack types are suicidal contracts. That's where anyone could kill the contract, which can have financial impact. Prodigal contracts, where anyone can send Ether to anyone, so you can actually move money to other folks. And greedy contracts, where it takes your money, but it doesn't let you do anything with it. So when it numbers in the millions, people tend to get angry. So Solidity is the language that we're using in smart contracts. It won by consensus, you could say. It beat out some other languages. It became the most popular. I wish I could stand up here and tell you that it is the most beautiful language I've ever seen. It's probably the farthest from the most beautiful language I've ever seen. It was designed originally, I see why they designed it the way they did. It's deterministic because it has to work with the blockchain. And they designed it in a way so it would look comfortable and familiar to people who do JavaScript and C. But as a result, this statically typed language that inherits libraries doesn't really hold up to security scrutiny. It's so sensitive to order. It's so sensitive to very slight changes in syntax. And we've had a lot of problems with it. So one day I'd like to see a replacement for this. You know, maybe someone will write it in this room. Who knows? But for now, we're kind of stuck with Solidity. So I used to joke that if you learn Solidity, you'll be like the 6th person to do so. But that's a complete exaggeration. It's more like the 10th person. So you might want to learn it. You know. So when I'm doing an ethical hack, there's surprisingly few tools in this place. I normally like to consider the development process. So you get a solve file, a .solve file. That's the Solidity code. Normally to run that, you would convert it to bytecode that runs on the EVM, and then you'd upload it to the blockchain. So when I look at it, it's still in code form. So I like to use Atom, a text editor, and it has plugins that allow you to see the highlighting for Solidity. So Language Ethereum lets you actually see at a glance what's going on. It's pretty helpful, especially if you are prone to making a mistake at 3 o'clock in the morning when you're late on a report or something. So it comes in quite handy. It also has an EtherAtom plugin that lets you try and compile the code to see if it works. You can also use Remix on a browser. So that's always a good first step, just to get familiar with the code when you get it. But there are some pretty interesting tools. One of them is Oyente. It was the first one to come out, and it keeps getting better. And they're very silent about it. They don't even make a big splash like, oh, we added all these vulnerabilities. They just kind of release it and don't tell anyone. So literally when I was pitching this talk, there were 2 less vulnerabilities it looked for, and I had to go in and change my slides at the last minute because now it searches for 2 more. But what's pretty great about it is it symbolically executes the way the EVM would, and goes through the flows of the program. Manticore does something similar too. With Oyente, you can search for integer underflow, overflow, parity multibug 2, the call stack attack, reentrancy, the one from the DAO. And I'm going to show a little demo later just so you guys get a sense of how that runs. It's pretty simple. The only catch is it's very temperamental with versions of the obscure dependencies. So there are Dockers that are published by the tool developers. So I usually just take the latest one, do a commit, after I add other tools I need, and then I use it as like a little mini Oriente thing. Because it's super temperamental. It'll be running fine, and then you'll update Z3 theorem prover, and then you'll go to run Oriente. It'll be like, whoa, alert, alert, fire. It won't run, So I like to do a Docker commit. Docker's very helpful for demos too, by the way. Those same guys started working on a project called Mayan, and Mayan is the tool that I alluded to with that 34,000 vulnerabilities that were found. As you can see, it checks for prodigal, suicidal, and greedy, those types of vulnerabilities I talked about. But what's super dangerous about Mayan is, it's a little hard to see on that slide, but to the right, you'll see that when you execute it, it not only tells you that a vulnerability is present, it actually shows you the exact line and shows you the exact injection you would require. So, hey, this is vulnerable. Try inserting this, and you'll kill the contract. So I'm very worried that this is going to introduce a new level of Ethereum script kiddie. So all of a sudden you're going to have these kids who know like literally nothing running Mayan and locking people out of accounts and like, swiping millions of dollars in ETH, So, I mean, the more I say this, the more my phone rings. So what are you going to do? So the basic methodology, when you're doing an ethical hack, what's the most dreaded thing, right? It's a kickoff call. No one really wants to talk to anyone. Everyone thinks their app is super special, and they walk you through it, and you're like, oh my God, I've seen this a million times. I don't want to see this again. Well, with Solidity, it's actually good to take that call. It's good to talk to the devs and get a sense of what the code does. You always want to do that. Then you want to review the solve file. You want to try and look and see if what they said is actually in line with what it does. Try compiling it, make sure they didn't give you buggy code. But then you want to run those tools I mentioned and kind of cross-index and see, because they all look for slightly different things and they're all a little better or worse at finding them. So often you can get a lot of low-hanging fruit quickly, like that. And by low-hanging fruit in this case, I don't mean the typical low-hanging fruit like, cookie issues. No, this is more like, hey, you can steal $10 million. So a lot of times you find it that quickly, but then it's good to manually check for vulns. So the first one we're going to look at is actually the one from the DAO. It's reentrancy. Now, as I mentioned, Solidity is very dependent on the order of executions. So every once in a while what will happen is you'll have a situation where money is sent and then the accounting happens afterwards. And that's a very bad thing. It sounds logical, it sounds like the flow you'd expect, but it allows for something very dangerous in a program that's read one line at a time and executed firmly one line at a time. So in line 7, which is highlighted there with the little explosion, that's actually doing a call to send money out. Now, the best way to do this would be to have it be what's called literally a send, but very few contracts would allow that situation. It's probably a little too abstract to go into, but for most of the times you're going to have to use the call. So what you want to do is not have this situation. So if the money goes, and then the accounting's taken care of on line 8, the balance is zeroed out, you have a situation where a race can occur and someone could continue taking money from line 7. And that's what happened with the DAO. So the DAO was, boom, 3.6 million Ether later, someone caught it and they stopped it, but it was a little too late. So watch lines 7 and 8 very carefully, and I'm going to show you this mind-numbingly beautiful fix. That's really it. You just switch those two lines. You do the accounting first, because you're expecting that to be the end of the run, and then you allow the money to be taken out in line 8. So, in case you missed it, that's really the dramatic change right there. Doing that alone will handle the Solidity flow. And what's amazing is, if you look at the big ticket hacks that have happened in this space, it's always been like one missing word, one line in the wrong place, and that's it. Not a whole like wonky function or anything. It's just always been something goofy like this. So in the original DAO, there's some irony because the withdrawal happens and then all the balances are zeroed out after that, just like in the example. I wrote the other example to be simple. This is a little longer. But it's funny because it says be nice and get his rewards. He sure did. He was never caught and he's sitting on $2 billion. So that's pretty entertaining, I think. Okay, let's see real quick here. Okay, we'll try a little something. All right, so over here we have some code, a little version. Oh, and I didn't realize how incredibly small that would look. All right, so there's some code running there, and it has, I made it line 7 and 8 just to be the same. It's that same idea that the accounting happens after. And then if you run, let's see if this is visible. If you run Oriente, Yeah, that's somehow really pixelated and blurry looking. But what you can see here is that it shows you the types and it says false, and then for reentrancy it says true, and then now it actually says the line. It's hard to see there, but it actually shows you the line of the code that's vulnerable. And Oyente didn't used to do that. It used to just say true, and you're like, great, I have 1,000 lines of code. Where is it? You know, and then you just have to like hunt through. But now, even though I didn't realize it would be so difficult to see, now you can actually find the line, you know, in the blink of an eye. So that makes this tool ever so much more popular and powerful. Okay. And okay. So another attack that was pretty devastating, this one was good for $32 million. The reason this one was kind of embarrassing is Gavin Wood was one of the 4 people who developed Solidity. I'll stay to the side. And he started this company called Parity. And as one of the developers of the language, he really should have known better than to make the mistake here. So the lines in pink are the way the code originally appeared. Now in Solidity, and in green are the replacements. So in Solidity, functions have visibilities. And if you don't declare whether it's internal, external, public, or private, the default becomes public. So it's just written that way. If you don't take the time to declare it, it's like, we'll just give it to everyone. You know, that's probably not the way you want to design a secure language, right, in general. But they forgot to do anything, and therefore all of these declarations were public. Now, these declarations allowed for the calling of a wallet. So a clever attacker realized that he can now run initWallet against those because it's public, and do something really simple, like request that the wallet now belongs to him. And it worked with one request. That's it. After that one request, it was just one more simple request to then siphon the money from the wallet to another account. The first 3 wallets he did that to were involved in ICOs. So he was able to move $32 million in seconds, just like that. This other group called the White Hat Group, they realized this was going on, and in a race against time, they started doing the same attack to everyone else remaining inside the Parity system, and they were able to save $200 million by moving it out of those accounts, holding it, and then, as promised, returning it in 10 days when the bug was fixed. Which is good, because if they didn't return it, they'd have to change their name. They couldn't be called the White Hat Group anymore. That would be a terrible name. So, but again, one word. That's it. One word. And it was all. So, pretty devastating attack right there. But poor Parity, it wasn't done. So, a few months later, they had a multisig wallet attack. Now, multisig, you know, multi-signature, it's a great idea, you know, requiring multiple signatures. Wow, what could be more secure than that? Well, the problem is they all used a single library, and it was not initialized properly. So that allowed someone to become the owner again, just like the last time, except something a little more devastating was done here. So this guy DevOps said he accidentally did these 2 transactions. Now, have you ever done any 2 things in a row accidentally? I never have. I mean, that's insane, right? Like, I accidentally fell down the flight of stairs and launched a nuclear missile. Like, I don't think those 2 things can happen. So that's kind of like what happened here. So he did an initWallet, again, similar request. And this one allowed him to own the library that all the wallets shared. And then in the next accidental request, he was, you know, able to kill it. Literally kill it. So what was the result? Well, that's 578 wallets frozen. There's no way to get that money back. And it's only, give or take, 513,000 ETH, which is about $317 million right now. So that's what happened accidentally. So I don't know about this, and I'm not sure what the outcome is going to be as far as this personal guy is concerned. But all because of sloppy library implementation. What they really should have done is they should have had a library construct, a stateless wallet, not something that could become a wallet. Another type of common thing, we're all familiar with overflows, right? So in Solidity, there is a possibility for overflows and underflows. I like to restore classic cars just for fun, and also because I'm huge and I don't really fit in modern ones. So in my 67 Impala, for example, does anyone know what happens after the odometer would say 99,999 miles? If I go one more mile, what's it going to say? Exactly. So that's what happens here. If you're at the max of the 256-bit number and you increment it by 1, you get 0. So that's pretty bad. But imagine now you could take that same odometer from 0 and go backwards. You'd end up at 99,999, right? That also is what happens in Solidity. So imagine a situation where you're decrementing your money, because you're spending it or whatever. And if a program isn't watching for this, when you get to a 0 value, if it's an unsigned integer and you try and spend again and the program's not written right, it'll be like, oh no, we've gone below, so just give him all the money he could possibly have. That's what would literally happen. So that's incredibly dangerous. So you don't want to have these happen. The simple fix, though, is to just use the Open Zeppelin math libraries. It prevents all that. It's just comical, though, that such a simple little thing can occur. In the early days of ETH, everyone seemed to be writing one type of smart contract over and over again. And that was the equivalent of a digital chain letter. Does anyone remember chain letters? You'd get in the mail and it'd be like, hey, mail this to 5 people with $1 to each. And then, they'll do the same and hopefully everyone's rich. Obviously, it never worked. So they decided to do something like this in Ethereum. And the concept was pretty simple. You would, again, this is the early days of Ethereum, so an ETH wasn't really worth anything. You would send an ETH to this contract, and you'd be king of the ether. Then for someone to depose you, they would have to send 1.5 ETH. And then they were king of the ether. And you would get their money minus a commission that goes to the contract, kind of like a VIG in gambling. So cool, everyone was happy. Seems fair, right? You could do this forever. You can, you're at 15 ETH, someone pays, another 7 or whatever, 22, and they're king of the ether. Now that would be an insane game. You'd be spending thousands of dollars, but that's how it worked back then. So unfortunately, when the unchecked send is made, it could go to a contract that's not owned by a human. And one of these not human contracts could have a mistake, an error in it. And with the right kind of error, that person who paid the money to become the new king of the ether will become the new king of the ether. The person who's expecting his payment will not get it, ever. So that becomes more than an unfair contract. It becomes a siphon of funds. And it's that very simple kind of thing that happened. So it's called unchecked send. And I simplified the code a bit just to show you how it works. So on the top, in Monarch send, what happens is you're sending that money out. You're sending the 500 out to say, hey, this person's going to be king. And then similar kind of to reentrancy, afterwards it says compensation sent is true. So the accounting happens right after. So the contract's like, I sent the money, the accounting's done, we're all good, let's move on with our lives. Unfortunately, if that external contract fails, you have a situation where that person's not going to get paid. The program thinks that the money went somewhere and it moves along happily. So a better way to do it would be on the bottom with a throw error. So what would happen is you're saying that if something goes wrong with the sending of the money, it'll throw an error rather than doing the compensation, which is a better way to do it. So one of those things that causes external errors is a gas limit. So you could think of the blocks on a blockchain kind of like a block-shaped Jeep. That's the last car analogy, I promise. So you can only hold so much gas in a car, in a Jeep, right? I mean, eventually you'll get that, I'd imagine. So there's a site called ethstats.net that lets you see at any given moment how much gas is currently available to hold in a block. Today it's pretty much exactly 8 million. It's like 8,062,000 or something like that. It's like really pretty precise. So that's how much gas. And gas is a small little unit of ether. It gets broken down. So you need to use gas to pay for things. You need to use gas to run the Ethereum global machine, right? It's sort of like an incentivized payment. Why should all these machines be running? It's not just mining, it's also running contracts. So these little bits of gas are paying literally to fuel the Ethereum machine. And it's a pretty efficient system. The problem is sometimes an error can happen because too little gas is included. So if you include, let's say, 2,300 gas, 2,300 gas is enough to log an incident, but not enough to actually complete a transaction. So that's how you can get sneaky and have those external contracts fail and have the problems like we discussed. I kind of wish it was 2600 though, so we'd have a new reason to use 2600, because that old one is like, not really relevant anymore. So there'd be a new Ethereum magazine called 2600. Everyone would get confused. So another version of it could be a form of denial of service. Rather than just the contract running and thinking it's paying people, you can set it up that if that money tries to go somewhere, it'll actually fail and then the contract will stop working and it becomes like a denial of service. And that's what's happening in line 11 here. It's trying to send the money, there's a contract failure, and then nothing else runs afterwards. So a better way to do this would be to have some kind of pull, not push. So to actually have a withdraw, not send situation, it's a little complicated, but basically you want to create a function for withdrawals. And that way, if worst case, someone tries to attack that withdrawal function with their own malicious contract, the only thing that'll happen is they'll end up failing against their own contract and they won't be able to harm anybody else. So the logic will know that something's up and it'll just keep flowing along. So that's really a better way to do that. A word on encryption. So the thing about the blockchain is it's supposed to be this distributed ledger that everyone can analyze at any time, right? As a result, it's pretty horrible for games of like guesses. If you have a game that accepts guesses over the blockchain, you can have a situation like this, reading from left to right. Like wrong guess number 1, wrong guess number 2, and then guesser number 3 says, oh, well, there's only a few left, and then they win because they saw what you said first. So that's a pretty dangerous situation if you want to take it if you want to take a game seriously on the blockchain. We are in Ethereum working on having some encryption right now, and I'm going to talk about that in a moment. But until then, it's not really the place for this type of game situation. Speaking of that order of blocks, every once in a while, it's possible that 2 requests come to a miner, and their transaction order might determine what happens. So it's not guaranteed that they're going to arrive at a set order and be acted on in a set order. So you can get a little sneaky. So in this contract here, around line 8, it sets up a puzzle. And then on the right side, it creates a sort of ability for the owner to change what the prize is at any time he or she wants. And from line 21 down, that's where the person would submit their guess to the contract. Now, what's dangerous here is if the owner is watching guesses being made, like we just saw, he could see that people are getting close and, oh, wait, someone might be really close. He can actually then try submitting, oh, the prize is not 10 ETH anymore, it's now 1. He could try and submit that. And with a transaction ordering dependence flaw, what would happen is the change request and the correct answer would arrive at the same time. At that point, it might be a 50-50 chance that he gets away with, providing less money as a payout. The other thing that can happen is he can offer a little extra gas or whatever to his transaction to make his go first. And as a result, he could cheat the system. He could say, you're going to win 10 ETH, and at the last minute, nope, you win 1, or even worse, nothing. So it's not good to have programs that are dependent on transaction order like that. What's better is to have something like a revealed commit. So think of it as sort of like a sealed envelope that everyone gets, and then after the contest, everyone gets the key, and it proves that you were honest in what you were giving away. So that's a better version if you want to have some kind of serious prize or something like that. This one that Oyente still looks for, call stack depth limit, isn't really a vulnerability anymore, so I like to highlight it because people get confused when they see it in the tool. So in the early days, you can only do 1,024 frames or calls to contracts. So it would be possible to do 1,023 of them and then put your malicious request, and then all chaos would ensue and your malicious request would get through. To fix that in EIP 150, Vitalik and others created a system where as you start approaching that last call stack depth, around 63 out of 64th percentage of the money, it starts to go up exponentially. So the cost of doing such an attack would be so expensive that I can't even see it really being worthwhile in the rarest of instances. So that's how they protect against the call stack depth attack. But for some reason, Oriente still flags it. I mean, I guess to point out sloppy coding, but it's not really a true vulnerability anymore. Sometimes people publish their contracts just to prove they're doing something honest, right? So in this case, we have an attack where a person can get sneaky and pretend that they're being all altruistic when they're not. In this case, we have in lines 3 and 8, the first two highlights, payout cursor ID. One of them ends with an underscore at the end, and one of them has no underscore at the end. That's really difficult to catch if you're just like quickly scanning through code. And then what actually happens down in line 12 is the money is incrementing in one, but paying out in the other. So everyone thinks in this game here that they're getting a chance at winning more money, but in reality, some secret zero account is getting all the money, and obviously that's probably the guy that wrote the contract. So that's another reason to use some kind of highlighting when you're auditing code, just to spot like where all the variables are and do they really have unique names, and is there any kind of like trickery going on. So a couple things I want to talk about. Timestamp dependence. It's not a good idea to ever have a contract that depends on the timing of a miner, because it's possible to change that timing by as much as 30 seconds without anyone noticing. So you don't want to have a situation where the timestamp of a miner means anything. If you can't handle a 30-second drift, that's not the way to do it. So that's another little silly thing to look for. Business logic flaws. This is something that should never leave hacking in general. It's great to have a methodology. It's great to have your checkboxes, especially if you have a big customer that requires you to say, yeah, you look for this, 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 and this. But at the end of the day, after you spend a lot of hours with a project and you really start to get to know it, that's where you get those eureka moments. That's where like 0 days are found. So with contracts, which really are nothing but logic, you do need to every once in a while just take a step back and kind of have that like logical look at it. The other potentially dangerous thing, since the launch of the Enterprise Ethereum Alliance, actually on Mardi Gras a couple of years ago, they started having these private versions of Ethereum at companies to do sorts of like internal business with these smart contracts. And then whenever you need to, you make a call out to greater Ethereum to settle up money or whatever like that. The most popular one is probably JPMC's Quorum. I've talked to those guys at length and looked at the code at length. And what it does is it separates public and private transactions. And pretty much all the companies are trying to do the same thing. So the way Quorum does it is it'll have something called private for, and whenever a transaction is private, it'll have a hashed representation in the blockchain. So if anyone sees it, it's literally meaningless to them. But then when the correct person sees it, this transaction manager can then send them the data that they're owned to. So you have to be really careful with what method you're using when you want to try and have your own in-house Ethereum and then have it phone home, so to speak. Because sometimes you might inadvertently be sending very private information out to a very public blockchain where it'll exist, pretty much till the end of time. So the Antithesis Alliance isn't really all that's coming either. There's some great things coming. Metropolis is pretty much where we're entering now. The new code, every code release of Ethereum has its own name. So Metropolis is what we're in now. And in this, we have new ways of handling errors. There's account abstraction. So for the first time, wallets in Ethereum might be post-quantum safe, whereas just about every other blockchain on the planet is not. So if someone gets a large enough quantum computer soon, for example, with Bitcoin, they'll be able to download the entire Bitcoin blockchain offline and slowly reverse everyone's private key that's ever spent a Bitcoin, ever. Including Satoshi, which is like over 1 million coins. So, I mean, I know I want a quantum computer. Now, the problem is the minute you do that, Bitcoin's value, I can promise you, you don't even need to check Coinbase, Bitcoin's value will go to a whopping 0, and that's where it'll stay forever. It'll be completely valueless as a cryptocurrency. But Metropolis is ensuring the first steps to making sure Ethereum doesn't fall prey to that. And also, most interestingly, is something called ZK snarks. So we're going to have these zero knowledge proofs. If you guys have heard of Zcash, the crypto primitives that make Zcash transactions private are now in Metropolis. It doesn't mean that Ethereum transactions are private yet. It just means the crypto primitives are there, and we could start working with the code. So pretty soon, you might be able to do all your transactions completely anonymously. So true zero knowledge. What's great about that is I believe in decentralization, and I believe in anonymity and privacy and a secure internet. But publicity-wise, this could be a rough few days for Ethereum when it happens. Because what do you think the newspapers are going to say? The new dark web money, buy drugs with Ethereum. That's all you're going to see. That's going to be pretty much all the headlines. And that's kind of like short-sighted. And on the topic decentralization, that is the real goal here. With Ethereum, the reason these smart contracts need to be secure is we're trying to build a Web 3.0 here, a new ecosystem of pure decentralization. If any of you guys saw Silicon Valley this year, they touched on it nicely without ever saying Ethereum, but that's the idea. The idea that you'll be able to store files on something called Swarm, which is kind of like IPFS or BitTorrent, but you have micro payments that incentivize servers to actually keep your files. So you could say, I want this file to last 10 years, and with those micro payments, it will. You know, it's not going to go anywhere. So there's no choke point, no centralization, no ability for someone to censor it. So Swarm's going to be pretty amazing to accomplish that part of the Web 3.0. So one day you might actually be able to open a browser and visit sites without any fear of anyone controlling it. So it's a pretty noble goal, and it might even make it easier to secure it with all the zero knowledge and privacy that'll be built in. If you could go back and build the web over again, you'd certainly do it differently than the way we did it in its insecure mess that it was. So that's why I think this is a worthwhile area to look into. And if you guys ever want, you can reach out to me there. And I guess we have some time for a couple questions. I tried to move it along since there's like brass bands and things going on out there. So sure.
Just a general question. To your point about the decentralization and privacy of the headline that's come out, is there a legitimate concern behind this? Obviously.
Well, sure. You could say that about any security, right? Like talk about hoarding of 0 days. Any government's view of hoarding of 0 days would be it's great. We have these to attack our enemies and keep our country safe. That's that view. But then you'll have something like the Vault 7 leak or the NSA leak, and then all the tools are out there, and then you get new 0 days that are hitting people that weren't prepared, and there's that side of it too.